The Nyquist plot of the open loop transfer function of a closed loop control system passes through the minus 1 plus j0. Minus 1 plus j0. Then the phase margin of the system is what? The phase margin of the system is. Let us take randomly one plot. I am taking one simple polar plot. Let us take, this is the polar plot I have chosen. This is the polar plot I have chosen. And this point, let me choose another color. And that particular point is, let me choose the black color one. This particular point is minus 1 plus j0. If that polar plot, or you can say Nyquist plot, polar plot and Nyquist plot both are similar. Like other Nyquist plot will be how you are going to draw. Its mirror image you have to draw. And if any pole at origin, double pole at origin will decide the encirclements. Right? So that's why simply taken only polar plot. Now see minus 1 plus j0, if it is passing through, it is not completely enclosed, it is passing through that. So then such systems are called marginally stable system. Such systems are called marginally stable system. So if this is so marginally stable system, then what is its angle GSHS? Angle GSHS simply minus 180 degrees. Because it is exactly passing through it. Na? So therefore what is the phase margin? Therefore what is the phase margin? Phase margin is 180 degrees plus angle GSHS. Na? 180 degrees plus angle GSHS, the phase margin formula. So therefore 180 degrees minus 180 degrees, which is equals to 0 degrees. Take a note here. Phase margin for a marginally stable system. For a marginally stable system is always 0 degrees. So no need to do this much calculation. Straight away we can put this. Provided marginally stable means it has to pass us through this minus 1 plus j0. Then only we can say the system is marginally stable, and you can directly write it like phase margin is equal to 0 degrees for marginally stable system. Okay. I hope it is clear. Now let us see another question. The magnitude of frequency response under damped response, that is like under damped system, is 5 at 0 radians per second and peaks to 10 by root 3 at 5 root 2 radians per second. The transfer function of the system is. Okay. So the magnitude of the frequency response is 5 at 0 radians per second. So therefore I need to calculate which of the following will give you that at 0 radians per second you are getting the magnitude 5. So you simply do one thing, put S is equal to j omega, this is 0, 5 by 100, I can say this is 5. This is 0, 375 by 75. First thing you take, option A, when you take, put S equal to 0 in this, what you will get? 500 by 100. Which is equals to 5. In this, put omega is equal to 0. 375 by 75. 375 divided by 75, how much? 25 3s, 25 1s are 25. I can say 4 plus 4 plus 12. So 300, 12 plus 3, 15, and this is also you are getting 5. Okay, option this 0, 720 by 144. 720 by 144, and if you calculate this, how much you will get? Wait, 720 by 144. Still here also you will get 5, and D 1125 divided by 225. I think it is also 5. You will get 5. So in all the cases you got 5. So all options are very close to this. Now peaks to 10 by root 3. Peaks to means resonant peak. Resonant peak. So what is the resonant peak formula? 1 upon 2 zeta into root over 1 minus zeta square, which is equals to how much? 10 upon root 3. Now rearrange this. Can I say, which is nothing but 3 by 100 is equals to, I mean squaring on both sides, I am shifting, 4 zeta square into 1 minus zeta square, right? You simplify this, what you will get the zeta? So we got zeta value is 0.25, valid value 0.25. If you simplify, you will get zeta value is 0.25. Zeta square value is 0.25. From this, zeta is equals to 0.5. So which of these options will offer zeta equals to 0.5? Which of these options you check from this? 2 zeta, what is omega n? 10 na? Because 100 is nothing but 10 square. Omega n square means 10 square. Omega n is equal to 10. 2 zeta into 10 is equals to 10. So 10 gets cancelled. Therefore zeta is equal to 0.5. Okay. So out of all these 4 options, this option is correct. So because in the question he is directly mentioned what is the value of this peak, resonant peak. Peak means resonant peak. So we know that MR is equal to 1 by 2 zeta into root over 1 minus zeta square, which is nothing but 10 by root 3. And finally you got the zeta value. Clear na? So now let us see the next question. So now let us see few questions related to the state space. So how to deal this state space problem? So actually what they are asking, they have given dx of t by dt is equal to matrix A and bu y is equal to cx. Like generally represent like state space model representation is x dot is equals to ax plus bu, y is equal to cx plus du. Okay, so here they have not asked anything about d, so you can eliminate the d. Y is equal to cx only directly will take, where x is the vector. So let me call upon this is x1 and x2. Why only we have taken x1, x2? Because it is a second order system, 2 by 2 matrix na? Yeah. So now they have already calculated what is b and all, and we need to see what is c1 and c2. So for that, let us write this equation. So can I write, this is called x dot of t is equals to, like let me put this matrix as it is, minus 1, 0, 0, minus 2, okay, into what is x? x1 and x2, right, plus this is b into u. Can we say that? Yeah. So now can we write like this, minus x1 plus 0 x2. Just I am doing basic multiplication, plus u. And similarly this is, you can say x1 dot. Similarly x2 dot is equals to what? 0 x1 minus 2 x2 plus u. So after getting these two equations, now what we have to do? We need to calculate this x1 dot, which is equals to minus x1 plus u, minus x1 plus u. Okay. Now similarly write x2 dot is equals to, what is that, minus 2x2 plus u. Can we say this? Just basic equations I wrote. Now on the other hand, they have given the transfer function, the elements C1, C2 represent respectively are they asking. So can I write this equation like this? Y of s by u of s is equals to 1 upon, how to write this is s square plus 3s plus 2. Let us do the partial fractions to this. You see, this is the transfer function 1 by s square plus 3s plus 2. Let me take the same. Y of s by x of s is equals to, can we write it like this? 1 upon s plus 1 into s plus 2, because this is simply s square plus 3s plus 2. Now, if you factorize it, you will get this. Now, tell me this. Can I write it like a by s plus 1 plus b by s plus 2? So here x of s is nothing but simply, this is also can be written like u of s. Okay. Now can you calculate what is a and b values are? So for that, this is 1 upon s plus 1 into s plus 2. Now let us do this. As plus 2a taking LCM plus bs plus b, which is equals to 1. Now compare the coefficients of s a plus b equals to 0, 2a plus b equals to 1. Now solve these two equations. I will get what? A equals to, if you cancel out this p, you will get minus 1, because a minus 2a minus a, 0 minus 1, sorry, 1. Now what about b? B equal to minus 1. So finally we got AB values. So once if you got AB values, now let us take equation. Y of s is equals to, can I write it like u by s plus 1? U by s plus 1, can we write it like this u? It will go this side, na? I will write it like this. Y of s by u of s. After getting a, I kept here a, so multiplied with u. A by u by s plus 1 minus u by s plus 2. Right na? Minus u by s plus 2. Let us consider this y of s as like this. Let us consider this y of s like this. What is that? x1 plus x2. x1 plus x2. Let us consider like this. Now, what is here x1? Can I say u by s plus 1? U by s plus 1. Now, from this, can I write s x1 plus x1 is equals to u, right? S x1 indicates, can I say it is x1 dot is equal to u minus x1, u minus x1. Similarly, you tell me what is x2? Minus u by s plus 2. From this, sx2 plus 2x2 is equals to minus u. From this, x2 dot is equals to minus u minus 2x2. Can we write like this? So from this we can say the matrix A is equals to, as per this data, A we got this, B we got this, and what about the C value? C value is going to be, we can say 1 minus of minus 1, it is 1. So our objective is to get the x1 and x2 dot values in terms of u. Once you got that u, we can easily get it. Okay. Now let us see this question. So in this question, if you see, it is in our standard form. What is that? In standard form, our equation. So what is that standard form? It is a controllable canonical form. How generally controllable canonical form we will represent? 0, 1, 0, 0, 0, 1, minus 2, minus 3, minus 4, or you can say generalized manner, I will tell you. Minus A0, minus A1, minus, okay, minus A0, minus A2, minus A1. This is A matrix, and for the B matrix is B0, B1, B2, and C0 is C2, C1, C0, or sorry, C0, C1 and C2. Okay, so how generally we are going to represent this? So for what characteristic equation, which is nothing but y of s by x of s. Let us say for third order equation, s cube plus a1 s square plus a2 s plus a0. Okay, into in the numerator we can say b0 s1 square, or you can say simply s1 square plus b0 s, like that. So now we will directly comparing that. So from this, can I say in the denominator what I will get? S cube I will get. In all the cases everything is same, plus 4s square plus 3s plus 2. Now what else left? 6, 5, 1 and b is 3. 6, 5, 1. So how to deal with that? 6, 5, 1. 6, 5, 1. So I need to take a 3 common in this. If I take common 3 in the last term, s square plus 5s plus 6 na. You see now, if I take the common term b, I will get 6 here, 5 here, 1 here, and this will be here. Got it now? I hope it is clear. Right? So this is they are asking simply what is the value of A. Is it looks like our standard form? Can we say that? It is looks like which form? Controllable canonical form, but which order? It is a 2 by 2 matrix. So what is that? 0, 1 minus A0 minus A1. Okay. So from this A0 value anyway you see here 4. So therefore what is the A value? Straight away we can say it is 5 only. Right. This is the one. Okay. Now let us see this thing. So what is they asking? Eigenvalues of the matrix. So generally eigenvalues of the matrix is, eigenvalues are nothing but what? Poles of the characteristic equation. Characteristic equation poles are nothing but eigenvalues. So what are the roots of it? Minus 5 plus or minus root of b square 25 minus 4ac 16 by 2a. Right? Minus 5 plus or minus root 9 by 2. Minus 5 plus or minus 3 by 2, which is nothing but minus 1 comma minus 4. Minus 1 comma minus 4. So here hint is what? Eigenvalues are nothing but roots of the characteristic equation. Roots of the characteristic equation is nothing but eigenvalues. So no need to do like comparison, this and that, you need not to do that. Okay. Now let us see. So this is our standard notation only. So straight away we can say minus 1, minus 2, minus 4. है ना? Minus 1, minus 2, minus 4. I mean like even though it is plus 2, it will become minus of minus, right? So it will be, so this is the answer. Okay. Therefore such questions you have to solve within 1 or 2 seconds. Straight away we have to see that. Okay.